We use logarithms as a way to simplify exponential equations and find the inverses. Exponential and logarithmic equations are two different ways of expressing the same relationship. We can change an exponential equation into a logarithmic equation because we know that a logarithm, or log, is an exponent. We know that an exponential equation is y equals b to the x, and logarithmic equation is y equals log base b of x. We say y is a logarithm to the base b of x. These formulas interchange once we take the inverse of the exponential equation. We can rewrite the exponential equation as a logarithmic equation by putting the exponent, or y, on the left-hand side of the equation, make the number the y was raised to the base, and then x becomes the number in the log. We use the change of base formula when trying to find the answer for the logarithm that is not base 10. We say that log base b of a equals log a divided by log b. Moving on to logarithmic properties, we use these formulas for condensing and expanding logarithmic equations. We can expand them so it is easier to visualize and condense logarithmic equations when we try to solve for a solution. It is important to note that the base stays the same when expanding or condensing logarithmic equations. The logarithms of products say that when we multiply two numbers or variables together, we can write it as log base b of c plus log base b of d. We apply similar steps with the logarithms of quotients. Instead of adding the two numbers or variables together, we subtract them. We get log base b of c minus log base b of d. The power rule allows us to move the exponent or power of the value within the log to the front of the log. We use this to simplify the power of the logarithm. Another important aspect of logarithms is common and natural logs. These are very similar to the logs we have already learned. When the base is 10, you get a logarithm called the common logarithm. It looks like log base 10 of x, which is always written as log of x. When using a calculator, you can use the log button. The common logarithm is important because it tells you how big the number is in decimal form, or how many times you need to use 10 in multiplication. When the base is e, we get the natural logarithm log base e of x, which is more commonly written as ln of x. Base e and natural logs cancel each other out. We can say ln times e to the x equals x, and e raised to ln of x equals x. On a calculator, the natural logarithm is the ln button. When we put it all together, we can solve exponential and logarithmic equations by using our knowledge of logarithmic, common log, and natural log rules. We use these tools to help us find a solution. The procedure we use in solving exponential and logarithmic equations are 1. Make sure all the bases are the same within the equation. 2. Condense the bases with the properties of logarithmic, natural logs, or exponents. 3. Once we simplify, we can solve for the solution. The example on the right uses both the power rule and product rule to simplify. Once we move the 2 to make the left side of the equation x squared, and use the product rule to simplify the 4 and the x minus 1, we can eliminate the logs and solve for x. If we use the properties and apply our knowledge of inverses, we can easily simplify the exponential and logarithmic equations. Good luck on your test. Be sure to study tonight.